Welcome back to Gaffy's Grinds. This is the channel where we take difficult concepts from leaving Cert Chemistry, break them down and help you to understand them a bit better, and then we'll give you some practice to do. This is video 5 in our organic chemistry series, and we are going to be looking today at naming alkanes. Before we start, some reminders: turn off your phone and put it in another room, and close all tabs on your computer apart from this one. Again, why? The purpose of that really is just to make sure we don't get distracted. We get through this nice, quickly and efficiently. The most important thing is when I ask you to do questions or tasks during this video, it's really, really important that you get that you go and do them, because if you don't, you're not going to learn basically as much, or definitely not as much, but maybe not even anything. So it's really, really important. If you do the things I ask you to do, I promise you will learn stuff. If you don't, you won't. Okay, so we're going to get stuck in today's video. A reminder that in previous videos, we learned about a family of organic compounds called the alkanes, and we learned how to name some simple alkanes. For example, we took an alkane with 5 carbons like this, 1, 2, 3, 4, 5 carbons, and each of these lines connects a carbon to a hydrogen. Okay, so I'm not going to write all the hydrogens on the end of this now, okay, but you can assume that each of them lines has a hydrogen on the end like that. So for all of them. Okay, now what I want you to do is I want you to tell me, speak out now to your video, what is the name of this alkane? I hope that you said pentane. P-E-N-T-A-N-E. Why is it pentane? Well, we learned that to count in chemistry, if we have 5 carbons, we count carbons. If we have 5 of them, we have the prefix pent. So this is a prefix. And then the family this belongs to is the alkanes. The reason why it's the alkanes is because we have all single bonds between the carbons. So any substance with all carbons with single bonds between them, we say has the functional group C, single bond C, and it belongs to the family of alkanes. This is the suffix. It's the last part of the name. So when we put the prefix and the suffix together, we get the name pentane, this substance. Okay, we then learned about isomers. We learned that if we take this substance, C, 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 and we add another C instead of a hydrogen on the side here. Well, we learned that if we were to count up all the carbons and hydrogens, we would have the same molecular formula as this substance. So if we count carbons here, we have 5 carbons, so it's C5. If we count the hydrogens, we would see that we have 12 hydrogens, C5H12. Now, this one looks different because we've got not 5 carbons in a straight chain. We've got 1, 2, 3, 4, 5 carbons still though, so it's C5, and if you count all the hydrogens, you'll learn that it's also H12. So both of these have the same molecular formula, but they're clearly not the exact same substance. So we say that these two things are isomers of each other, isomers. Okay, so they have the same molecular formula, but different structural formula. Now, why is this important? Well, it's important because these two things will have different names. So this one is pentane, but this one is not going to be called pentane. So because of isomers and the existence of these are what we call branches, this is a branch of a hydrocarbon, we have to have a naming system. So today we're going to look at the naming systems. Now, because molecules can be either straight like this one, branched, and we know that they can also be cyclic. So cyclic are rings, and we need some rules for how we're going to name them depending on what they look like. So we've already learned how to name a straight chain like this, okay? How to name a straight chain alkane. But I'm now going to show you how to name an alkane with branches. Now, before we do that, we need to know the names of some of the branches, okay? Now, first of all, sometimes in organic chemistry, you will see the letter or attached to, say, a carbon, which is attached to something like this, okay? You'll see something like this. And an or, there is no element which is or. So this is not an atom of or. What this basically means is this is a chain. Okay, it's a chain of molecules or chain of atoms. Okay, and it's called an alkyl group. An alkyl group. Now that OR could be C, C, C. It could be 3 carbons long, or it could be C, 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 C. It could be 5 carbons long. It could be 300 carbons long. But it's basically telling us that we have what we call an alkyl group, which is basically a carbon chained branch. So it's an alkyl group. Now we see this bit, the YL. This is going to be important, and why I've explained that to you is the groups, anything sticking off the side of a molecule, the main molecule, we call an alkyl group. Alkyl, A-L-K-Y-L. Okay, why is that important? Well, if that OR is equal to 1C with 3 H's. Okay, if OR is equal to 1C with 3 H's. So where would we see that? So say we've got a carbon chain with 4 carbons, and on one of the carbons we have this here, a C with 3 H's. I hope that you can see that that's just that guy there. This then is an alkyl group. It's an OR group. It's an alkyl group. Now, the next thing, so if it's an alkyl group, it's going to have the name, it's going to end in the suffix YL. Suffix is going to be YL. Okay. Now, the prefix, the first part of the name, comes from how many carbons we have. So the exact same as when we counted carbons before. Methane was an alkane with 1 carbon. This is going to be METHYL. This is a methyl group. So if we've got 1 carbon like this, it's called a methyl group. Okay. Now, if our OR is equal to this, 2 carbons surrounded by hydrogens. Okay, so where will we see that? Well, if we've got 1, 2, 3, 4, 5, 6, 7. Okay. And then here we've got 1, 2. Hopefully you can see here that this is an OR group, and this is this OR group. Okay, it's got 2 carbons and it's attached to a long carbon chain. This here is going to be an ethyl because it's 2 carbons, ETH, YL. So if we've got this guy, it's going to be called an ethyl. Now, very quickly, sorry, I should have done this for the first one, but if we were to just write out what the molecular formula of this is, it's going to be C2H5. So an ethyl group has a molecular formula of C2H5. Methyl, what we did in the last, just before, methyl had 1 carbon, so C, and it had 3 hydrogens, so CH3 group is a methyl group. Okay, hopefully you can predict what the next one is going to be. Something I'll. What if the OR was like this? YL, it's going to end in YL. What if OR equaled 3 carbons surrounded by hydrogens? What if it was 3 carbons surrounded by hydrogens? Speak your answer now to the screen. I hope that you said propyl. Now, for me, I want you now to pause your video and try to write down the molecular formula of this substance. Okay, so you should be watching the video if you have paused and tried to write down the molecular formula of propyl. You should have written, I hope you wrote C3H7. C3H7 would be a propyl group. Okay, now, another one that we can sometimes see, it's rare that we see this, but we can also see it, is where we've got a benzene ring attached. and we've got a benzene ring attached to our main chain. So this one is going to be called benzyl. Benzyl. So only one Z. Sorry, BENZYL. Benzyl group. Okay, and that is going to have the molecular formula. We've got 6. Remember, each point is a carbon. So we're going to have C6, and each one has 1 hydrogen. C6H5. It's going to be a benzyl group. There are some times where you can have groups attached that are not carbon-based. For example, if OR was equal to a chlorine, Cl. If the OR group was a chlorine, then this would be chloro. Okay, so chloro, that would be just a Cl. And if OR was a bromine, BOR, then we would have bromo. And the formula for that would be BR. The last thing I suppose to remind you is that sometimes you can have 2 OR groups. And they could have 2 of these guys. So imagine we've got a carbon chain like this, 4 carbons, and on this carbon we've got 2 of those groups. We've got 2 methyl groups. We would signify this by writing di. Di means 2 of them, so dimethyl. What if we had a third one like that? And then we would have trimethyl. Okay, right. At this point, what I want you to do is I want you to pause your video, take down the names and the formulas of the different OR groups we can have. So you see them here. Okay, so these are the different branches we can have, the different OR groups. Ethyl, which is 2 carbons, methyl, 1 carbon, propyl, 3 carbons, benzyl is a benzyl ring, and then we've got chloro and bromo. Okay, so pause the video, take them down now, please. Okay, so now that you've done that, we know how to name the branches. I'm now going to show you how we can name a full molecule if we're given its displayed formula. So, say we have this hydrocarbon. We have C, single bond C, single bond C, C, and C. Okay, and I've got another C here, and I've got another one here. All right, so we're jumping straight into a pretty tough one here. So, just drawing the hydrogens. Remember, all carbons must have how many bonds altogether? On 3. Speak your answer to the screen. I hope you said that all the carbons must have 4 bonds. So you've got to check each carbon has 4 bonds. 1, 2. This carbon here has 1, 2, 3, 4. Good. This carbon only has 1 at the moment, so there's 1, 2, 3. So it's got 4 altogether now. 1, 2, 3, 4. This carbon has 1, 2, 3, 4. It's all good. This carbon has 1, 2, 3, 4. Good. This carbon has only 1 at the moment, so there's 2, 3, and 4. This carbon at the moment has this one and this one, so 2 altogether. There's another one and another one. Now it's got 4. This N carbon has 4. Okay, so now that's completely drawn out, and as you can see, it is quite messy. It does get quite cluttered. If you have more space, the bigger you can draw it, the less cluttered it is. Okay, so you could be given a question like this, showing a molecule like that, and you could be asked to identify or to give the name of this molecule. Right, so there's a couple of steps. Okay, the first thing that we need to do is identify where the longest chain of carbons is. So where is the longest chain of carbons? Continuous chain, longest continuous chain. Now, so I could start here. If I start at this carbon and go across here. Okay, here's a chain that goes 1 carbon, 2, 3, 4, 5. That's a chain of 5 carbons. Count them again. 1, 2, 3, 4, 5. All right, let's check, is there any other way we can go that would make it longer? All right, well, let's try this one. 1, 2, 3. Okay, that's not longer, so I can ignore that one. It's not that one. 1, 2, 3, it's not that one. Let's try this. 1, 2, 3, 4. Well, that's not longer than 5, so that's not right. Let's try counting from this side. 1, 2, 3, 4, 5. Well, that's the same as what I started with. So I could choose either of those if I wanted to. Either one of those. Either that straight one or that bent one. If I can choose the straight one, it's usually easier. So I'm going to stick with that one. Unless it's shorter, then you have to go with the curved one. In about 5, I'm going to stick with the straight one. Let's try this last one. That could be 1, 2, 3, 4. No. So 5 is the longest chain. So I'm going to use that as my longest chain. Those 5. Okay, so that's my longest chain of carbons. Now you have to name this parent molecule. You have to name this molecule. Okay. Well, first of all, we have to figure out it's got 5 carbons. So a 5 carbon chain, what is the base name? The base name, how many carbons, what is the name for 5 carbons? We say it's pent. 5 carbons is pent. Now, what family does it belong to? Well, I can see it's a saturated hydrocarbon. It's all C single bond Cs. There's no double bonds, and there's no, so it's all C single bond Cs. Now, the homologous series that this belongs to then is the alkanes. So this is going to be pentane. That is going to be the base name, the parent molecule. We call this the parent molecule. Okay, so step 1. What did we do? Step 1 was identify the longest continuous chain. That's what we did first. Now, step 2, we're going to take the carbon chain, this one here, and we're going to number the carbons. And we're going to start with the site. I could start here as number 1, or I could start here as number 1. I'm going to start with the site that's going to give us the lowest numbers for the branches. So if I start from this side, that would be 1, 2, and there's the first branch on number 3. 1, 2, that would be 3. If I start from this side, I've got 1, 2. The first branch is on 2. So I'm going to start from this side because it's going to give me the lower numbers for the branches. If I start from this side, my branches are going to be on carbon 1, 2, carbon 3, and carbon 4. If I start from this side, I'm going to have branches on carbon 2 and carbon 3. So this is the side I want to start from. Now I'm going to number them. So this is carbon 1, 2, 3, 4, 5. Okay, so numbering them, starting on the side that will give me the lowest numbers. Great, easy. Okay. So the next thing then is to identify the type and the position of branches. Okay, so this is correct numbering. This would not be correct numbering. One, 2, 3, 4, 5. This would be incorrect, not correct. This would give me too big a numbers for the branches. Right. So step 2 was we numbered the chain of carbons. Sorry, numbered the chain of carbons. Starting from the side which gives the lowest numbers for branches. Okay, so step 1 and step 2. One more step is we have to indicate the type and the position of the branches. Now, what are the branches? Well, here is the first branch. And here is the second branch. Now, from our previous learning today, what type of branches are they? Well, they're 1 carbon each. Okay, they're 1 carbon each, which means that they are called methyl. Methyl. So that we know there are 2 methyl branches. And which carbons are they on? Okay, well, they're on carbon 2 and carbon 3. On C2 and C3. So how do we show this? Well, we would write the position. The first thing we're going to do is write the number of the carbon that they're on. So they're on carbon 2, comma, and they're also on carbon 3. 2, 3. Then we put a dash. After we've said what position they are, then we're going to say what type of group they are. Well, they're methyl. 2, 3, methyl. Now, I explained to you before on the previous slide, what happens if we've got 2 of these? We've got 2 methyl groups. We put something in front of the methyl to show that there are 2. On 3, I want you to speak to your screen. What do we put before methyl to show that there are 2 of them? Okay, so on 3, 1, 2, 3. I'm hoping that you said dimethyl. So 2, 3, dimethyl, and then we put the parent name. So the parent name of this is 5 carbons, it's pentane. So 2, 3, dimethyl pentane. Okay, so that's the name of this compound. So step 3 is indicate the position and type of branches. Indicate the position and the type of branches. Now note, what about the commas and the dashes? Right. So put commas, put comma between numbers. This here. Put comma between numbers. Dashes between numbers and words. Like that. There's a dash between numbers and words. So comma between numbers, dash between numbers and words. Okay, so what I'm going to get to do now is I'm going to get to pause the video and take down that example, take down the 3 steps that we want to follow. So this is a modeled example, and I'm going to get you guys to do the same for some other ones now in a minute. Okay, we're going to do one together now. And I do suggest you try and do this from memory without looking at those steps for help. Okay, so I'm going to set it up for you. So we've got 1, 2, 3, 4, 5 carbons. Okay. Okay. Now, I'm not drawing in all the hydrogens. I'm just drawing the bonds. Now you can assume that every bond ends in a hydrogen. Okay. Just keeps it a bit tidier looking. There's nothing wrong with it. Each carbon still has 4 bonds, and you still know that at the end of them bonds is a hydrogen. Okay. So, step 1. What is the first thing we have to do here? If you know, pause your video and do step 1. If you don't know, you can watch me now. Okay. So, you should be playing the video. If you were confident and you paused it and you went and did step 1, you should be playing the video. If you didn't and you need some help, I'm going to do this with you now. Okay, well, I can see. I'm going to count the carbons here. I've got 1, 2, 3, 4, 5 carbons. Okay, let's see if there's any other way that will give me a longer chain. 1, 2, 3, 4. No, that's no good. 1, 2, 3, 4. Still no good. 1, 2, 3, 4. No, pretty sure now 5 carbons is the longest chain. So this 5 here. So I've identified the longest chain. That was step 1. Okay. If you know how to do step 2 and you're confident and you can do it, pause the video and go and do it now. If you're not confident, then you can stay and we'll do this a little bit together. Okay. Now, if you were able to do it, you should have already got it done. If not, you're doing it with me now. So the second step is to number the carbons, starting with the carbon that will give you the lowest numbers on the branches. Well, you will hopefully see that it doesn't really matter this time. It doesn't really matter because if we start from this side, this is going to be 1, 2, 3. Both branches will be on carbon 3. If we start from this side, 1, 2, 3, both branches are on carbon 3. So it really doesn't matter. So this is 1, 2, 3, 4, 5. Okay. Now, the parent molecule here is going to be pentane again. That's the parent molecule. So it's going to be something pentane. Now that we've numbered the carbons, we can now go to step 3. If you're confident on how to do step 3, pause the video and go and do it. If not, stay watching it with me. Okay, right. So let's identify step 3 is we've got to identify the type and number of branches. Okay, so identifying the type and the number of the branches. Well, I see I've got a branch here and a branch here. I've got 2 branches on carbon 3. And they are both, again, methyl groups. Okay, so how am I going to indicate the position of these? Well, I've got 2 methyl groups on carbon 3. So we show this by saying, okay, well, what carbons are they on? They're on 3 and 3. They're both on 3. So 3, 3. Now between a number and a word, we put a dash. So 3, 3, dash. There are 2 methyls, so it's going to be dimethyl pentane. Well done if you got that right. I just want to show you, before I set you off to do them on your own, what would happen if we have 2 carbons, 2 methyls on 1 carbon and 1 methyl on another carbon, something like that. 1, 2, 3, 4, 5, 6. Right. So what would happen if I had 2 methyl groups on this carbon and another methyl group on that carbon? What would happen in that case? Well, again, we would do the same thing, identify the longest chain, give us our parent name. That would be 1, 2, 3, 4, 5, 6 carbons, so it will be hexane. Hexane. Number them, 1, 2, 3, 4, 5, 6. Again, this gives me the lowest numbers on the branches. All right, so this is 2 methyl groups on carbon 2. If I start from this side, I wouldn't have a branch until carbon 3. Okay, so what have I got here? I've got a methyl group and another methyl group on carbon 2. So I've got 2 methyls groups on carbon 2. And I've got another one, a methyl group on carbon 4. 1 methyl group on carbon 4. So how do I show this? Well, I would say, start with the lowest number, 2, 2, and then there's also another one on carbon 4. 2, 2, 4. 2, 2, 4, and then dash How many methyls altogether? There's 2 here and 1 here. That's 3. So how do I say 3 here in front of methyl? It will be trimethyl and then hexane. All right, that one's a little bit more complicated, but it's still the same rules to follow. Okay, so it's your turn to do some practice now. All right, so these are some for you to practice, okay? You'll see that they are labeled underneath in pen. Sorry, it's a bit scribbly. It's hard to write on the screen with the funny pen, with the screen pen, the stylus. But they are labeled from left to right, A, B, C, D, E, F, G, and so on. Hopefully you can see that, make that out. Okay, so what I want you to do is I want you to name these compounds. You'll see the first 4 are pretty easy. They're just standard, they're just standard straight chained alkanes, and then we start to see a few with branches. Okay, so what I want you to do is in your practice copy or wherever you do your questions, is I want you to name each of these compounds for me using the rules that we just looked at. Try though to do it without looking back at the rules as best as you can. Okay, so try do that for me now. Pause your video and complete those, please. Okay, so you should only be now watching the video if you have tried to do all of those, if you have tried to draw all of those. I'm hoping they're pretty straightforward, and just having a quick look at them here myself. There's nothing too different or too complicated in any of those. So what I'm going to do now is I am going to show you the answers, and really guys, you should only be watching if you've tried to do these. You're wasting your time watching if you're not going to do the practice. Okay, so here are the answers. Okay, again, I hope that there's none of those that caused you too much problem. Okay, if you got those right, well done. If you didn't get them right, I suggest you go back and watch the bit about how to name them again. Okay, just watch, you might have missed something important, some of the rules. It's really important that you get that bit before we move on here. So I'm hoping that you did okay with them. If not, go back and watch the video. All right, the next thing is I have another task for you. I want you to identify out of that set of molecules, some of them are isomers of each other. So what I want you to do now is, if you think you know how to do this without me giving you a hint, if you're confident that you can go and figure out which ones of those are isomers, then pause your video now and go and do that. If you didn't pause the video, I'm presuming that you need some extra help with it. You need a hint. Okay, so I'm going to give you a hint of how you need to do this, or what you need to do in order to find out which ones. Well, if you think about the definition of an isomer, what is an isomer, or what are isomers? Isomers are substances with the same molecular formula, but different structural formulas. We can kind of see the structural formula or the displayed formula on the screen. What we don't know is the molecular formula. So what you need to do is, if you haven't already done this, you need to go and write down the molecular formulas for each one. And any of them that have the same molecular formula, but are different structural formulas, look different, those will be isomers of each other. So now pause your video and go and do that. Okay, again, you should only be watching the video if you have gone and written down the molecular formulas for each compound and then identified which ones were isomers. I'm going to show the answers now. A, B, and C have no isomers because they're just too small molecules to be arranged in any other ways. D and E are isomers of each other. So D and E are isomers of butane. They're both butane, or they both have the same molecular formula as butane. F, G, and H are isomers of each other. F, G, and H. I, J, K, L, and M are isomers. So 5 isomers. They all have the same molecular formula, but are arranged differently. And N has no isomers shown here. Okay. Now, that's not to say N has no isomers. It has lots of isomers. I just haven't shown them here. Okay. There's no other one that has the same molecular formula as that. Okay. Now, the next thing we're going to look at is cyclic hydrocarbons. Cyclic hydrocarbons. Now, if you think of the word cyclic or cycle, cyclic or cycle means round. So a bicycle is bi means 2, and cycle means wheel or round. Okay, so bicycle, 2 wheels. That's what it means. A tricycle has 3 wheels, so on. unicycle has one wheel. It's got to do with round or wheel. So cyclic hydrocarbons are ones with, if you like to think of it, a wheel, or they have a cycle in them, they're round. Okay, so when a hydrocarbon's longest chain of carbons forms a closed ring, we say we have a cyclic hydrocarbon. So this is a straight hydrocarbon with 6 carbons. 1, 2, 3, 4, 5, 6. This is something we're familiar with. We know that this is called hexane. Hexane. So the longest chain is a straight chain, and we call it hexane. Now, what happens though if these were to be joined together, the 2 carbons? So at the end, we were to take them and we were to twist them into a cycle, into a wheel or a ring. Okay, well then what would happen is that the 6 carbons, instead of being in a straight chain, would be connected to each other like that in a wheel. That's not a great drawing. I'm going to draw that again. C, 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 C. Okay. All right, so this is now what we call a cyclic hydrocarbon. Now, anytime we have a cyclic hydrocarbon, its name is going to begin with the word cyclo. Okay, so if this was hexane, then this is going to be cyclohexane. Cyclohexane. Now, cyclohexane still contains 6 carbon atoms, and they're all singly bonded, and they're in a closed ring. So 6 carbon atoms, and they're all singly bonded. That means it's still technically a type of an alkane. So we would expect it to be very similar in properties to this alkane, because it's got 6 carbons and it's the same structural form, or the same functional group, sorry, which means we'd expect its reactions to be very similar, its properties to be very similar. Sometimes if we were to draw just a skeletal formula, well, we don't need to draw the carbons and the hydrogens, we would just draw a line, we'll just draw a hexagon like that. The skeletal formula for this one would just be just like this. 1, 2, 3, 4, 5, 6 carbons. 1, 2, 3, 4, 5, 6 carbons. Okay, so these are the skeletal formulas. Now, hopefully you can see that if I wanted to take this carbon, pull it round and bond it with this carbon, that would mean that the hydrogens that are on the ends here would need to be removed to make space for these 2 carbons to connect to each other, because they'd have to bond to each other. So basically, what we're going to do here is we're going to have to remove 2 hydrogens to get this to go into a ring, which means the general formula for a cycloalkane, the general formula for a normal straight chain alkane is CnH2n plus 2 alkane. All alkanes have this formula, CnH2n plus 2, where N is the number of carbons. Now, because we've had to remove 2 hydrogens to make space for the 2 carbons at the end to join together in a ring, we're going to have to lose 2 hydrogens. So 2 of these hydrogens are going to get dropped, which means cycloalkanes have the general formula CnH2n. CnH2n. So, what will the formula of this cyclohexane be? So use this to work out the formula of cyclohexane. Speak out your answer to the screen. I'm hoping that you said C6, because there are 6 carbons, and that means H2N, 2 times 6 is H12, whereas this one is going to be C6H14, because it's CnH2n plus 2 for an alkane. So they will have slightly different general formulas. Okay, that's going to be important. Now, what about sorry, I'm not going to go into the other one. So we're going to now do some practice questions. But before we do, we're just going to take a look at a quick summary table of comparing alkanes with cycloalkanes. So first of all, both are saturated. The reason for this is there are no double or triple bonds. They're all C single bond C, so nothing's different there. They are both obviously hydrocarbons. There is nothing else, only hydrogen and carbon. This is where we start to see the first differences. The general formula, we just explained that. There's two extra hydrogens in an alkane, which are lost when the ring joins up in a cycloalkane. Obviously, we don't refer to a straight chain as cyclical, whereas a cycloalkane, we do refer to it as cyclical, just means ring. Neither of them have polar bonds. We will explain that in more detail at another time. They are both considered aliphatic. Why are they considered aliphatic? Speak your answer to the screen now. They are considered aliphatic because they don't contain a benzene ring. While the cyclohexane is a ring structure, it's not a benzene ring. A benzene ring would have a circle drawn inside. Okay, so have this ring structure and then it has a circle inside. This one is missing that. Okay, time for you to do some practice now. Nope. Okay, I want to pause the video and try the questions, please. Okay, you should only be watching the video if you have tried to do those questions. Okay, I'm going to show you the answers now. So draw the skeletal formula for the fifth member of the alkanes and the cycloalkanes. Okay, so the skeletal formula should look like this. So for the fifth member of the alkanes, it's 5 carbons. This is a skeletal formula, so we don't need to show the hydrogens. So each point is a carbon. So we've got 5 carbons. And in a ring structure, we basically have a pentagon. 5 carbons in a ring, we get a pentagon. The molecular formulas of each one, you will see, are slightly different. The alkane is C5H12, but the cycloalkane is C5H10, missing 2 hydrogens where the ring joins up. Explain why these two compounds are not structural isomers. Many people think they are structural isomers because they're both technically pentane. They're not, because they have different molecular formulas. So the molecular formula are different, with cyclopentane having 2 less hydrogens. We can see that on this line here, question 2. Define an isomer. So what is an isomer? Isomers are compounds with the same molecular formula but different structural formulas, just like these two up here. And why would you expect both alkanes and cycloalkanes to have similar reactions? Well, there's a couple of ways you can say this, but they would have similar reactions because they are both saturated, so they have all single bonds. They are both alkanes, and they both have the same functional group. Any of those answers, both saturated, both alkanes, and both they have the same functional group. All of those are good answers there. Okay, that's it for today. We have just learned today how to name alkanes, including branched alkanes. In the next lesson, we're going to be giving you the name and asking you to work backwards to draw the structures. So well done. I hope you found today's video useful. I hope you were able to answer the questions okay. If not, you can bang a question into the comment if you need me to explain anything into the comments under this video, and I will try and make another video that explains it. Well done. I'll see you in the next one.